Hello everyone. Today we have to solve problems on trigonometric ratios. So let us start. First example. Prove that cos of 21 degree minus sine of 21 degree divided by cos of 21 degree plus sine of 21 degree, and this is equal to, we have to prove tangent of 24 degree. Here on left hand side 21 degree angle is there, on right hand side 24 degree is angle. Okay, and 21 plus 24, that becomes 45 degree. So let us solve this sum considering angle 45 degree. Let us find tangent of 45 degree. Tan of 21 degree plus 24 degree, and this is equal to tan of 21 degree plus tan of 24 degree divided by 1 minus tangent ratio of 21 degree into 24 degree. Since we know this formula, tan of a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. Okay, here we are considering a is 21 degree, b is 24 degree, then this becomes tan of a plus b. Okay, and which is equal to tangent tan of 21 degree plus tan of 24 degree divided by 1 minus tan of 21 degree into tan of 24 degree. Okay, now left hand side becomes 21 degree plus 24 degree, that is nothing but tan of 45 degree. So we can write this tan of 45 degree is equal to whatever may be right hand side, keep it as it is, tan of 21 degree plus tan of 24 degree divided by 1 minus tan of 21 degree into tan of 24 degree. Now left hand side tan of 45 degree, which is equal to 1. So left hand side becomes 1 is equal to tan of 21 degree plus tan of 24 degree divided by 1 minus tan of 21 degree into tan of 24 degree. Okay, now we can write this taking cross multiplication. 1 into this denominator is equal to numerator of right hand side. So this can be written as 1 minus tan of 21 degree into tan of 24 degree is equal to tan of 21 degree plus tan of 24 degree. Now taking this term on left hand side and this term on right hand side, this can be written as 1 minus this tan 21 degree we are taking on left hand side, tan 21 degree is equal to tan of 24 degree plus tan of 21 degree into tan of 24 degree. Okay, now you can take tan of 24 degree common from right hand side. So this can be written as tan of 24 degree is taken common, and into bracket remains 1 plus this tan 21 degree. Okay, now take this 1 plus tan 21 degree on left hand side, then this can be written as 1 minus tan of 21 degree divided by 1 plus tan of 21 degree, and this is equal to tan 24 degree. And now on left hand side tan ratio you can convert in terms of sine and cosine, keeping right hand side as it is. Okay, so this can be written as 1 minus sine of 21 degree divided by cos of 21 degree for numerator, and then for denominator 1 plus tan 21 degree sine of 21 degree divided by cos of 21 degree, and this is equal to tan of 24 degree. Now numerator becomes cos 21 degree minus sine 21 degree, cos of 21 degree minus sine of 21 degree whole divided by this cos 21 degree, and now simplify denominator. So In denominator also, cos 21 degree plus sin 21 degree. Cos of 21 degree plus sin of 21 degree, and this divided by this cos 21 degree. Okay. So this is simplification on left hand side, keeping right hand side as it is, tan of 24 degree. Now this cos 21 degree cancels with this cos 21 degree. On left hand side, it becomes cos of 21 degree minus sin of 21 degree divided by this cos of 21 degree plus cos of 21 degree plus sin of 21 degree, keeping right hand side as it is, and which is the relation which we are going to prove. Okay, this is given statement which we have proved. Let us solve next sum. Example number 2. Prove that cos square into bracket 180 degree minus theta divided by sin of minus theta plus cos square into bracket 270 degree plus theta divided by sin of into bracket 180 degree plus theta is equal to minus cosec theta. Okay. Let us prove this. Taking LHS, we are going to prove RHS. Let us take LHS. LHS is equal to cos square means cos of 180 degree minus theta square of this plus divided by sin of minus theta plus cos square 270 degree plus theta divided by sin of 180 degree plus theta. Okay. First of all, we have to find out values of cos of 180 degree minus theta, cos of 270 degree plus theta, sin of 180 degree plus theta, and sin minus theta. Since we know sin of minus theta is equal to minus sin theta, as well as cos of into bracket 180 degree minus theta. This 180 degree in terms of multiple of 90 degree can be written as cos of into bracket 2 times 90 degree. 180 degree means 2 times 90 degree. And this minus theta here. Okay. Here multiple of 90 degree is 2, which is n. N is equal to 2, which is even number. And this implies this whole angle 2 times 90 degree minus theta. This whole angle lies in quadrant number 2. Okay. Because 2 times 90 degree lies on negative x-axis, and this minus sign indicates that quadrant number is previous of negative x-axis, and which is quadrant number 2. Okay. And you know, in quadrant number 2, cosine ratio is negative. So due to this quadrant number, we can put here minus sign, and due to this n is equal to even number, cosine ratio remains cosine as it is. So cos of this acute angle theta minus cos theta. So cos of 180 degree minus theta is equal to minus cos theta. Then cos of 270 degree plus theta. We have to find out value of this. You know, 270 degree can be written as 3 into 90 degree, and this plus theta here. 3 times 90 degree means negative y-axis, and this lies on negative y-axis. Plus indicates that next quadrant next to negative y-axis. After negative y-axis, there will be only quadrant number 4. Okay. Quadrant number we get 4, and n is 3, which is odd number. Due to n odd number, cosine ratio changes into sine, and due to quadrant number 4, in quadrant number 4 cosine ratio will be positive, so here plus sign. Hence cos of 270 degree plus theta can be written as sin theta. Then sin of 180 degree plus theta is equal to, we can write sin of 2 times 90 degree plus theta. 2 times 90 degree, again this lies on negative x-axis, and this plus indicates that negative x-axis, its next quadrant, that will be quadrant number 3. Hence quadrant number we get 3, and n is 2, which is even number. N is even number. Due to n even number, sine ratio remains sine with acute angle theta, and this minus sign due to this quadrant number 3. Because in quadrant number 3, only tan and cot are positive, remaining all trigonometric ratios are negative. So sine also becomes negative, minus sine theta. Now we have to put all these values here. So we can write LHS is equal to, on right hand side, cos square 180 degree minus theta. But cos 180 minus theta is minus cos theta. Minus cos theta square of this divided by sine minus theta means minus sine theta plus cos square 270 degree plus theta. But you know cos of 270 degree plus theta is sine theta. It's square. So sine theta square of this divided by sine of 180 degree plus theta. But you know sine of 180 degree plus theta is minus sine theta. So we can put here minus sine theta. So simplify this. This is equal to, we can write this minus square, that becomes plus. So this is equal to cos square theta divided by minus sine theta. Due to this plus into minus sine square theta divided by sine theta. Okay. Now from these two terms we can take minus sine and minus 1 upon sine theta common. So this is equal to minus 1 upon sine theta is taken common, into bracket remains cos square theta plus sine square theta. But this is trigonometrical identity. Cos square theta plus sine square theta is equal to 1. Hence we can write this is equal to minus 1 upon sine theta into this 1. But minus 1 upon sine theta is minus cosec theta, because 1 upon sine theta is cosec theta. Hence this is equal to minus of cosec theta, and this is equal to right hand side of given statement. Hence the proof. Let us solve sum number 3. If tan A is equal to half, comma, tan B is equal to 1 upon 3, then find tan of A plus B. Let us solve this sum. Since we know tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. Okay. Here tan A is equal to half. This is given. Tan B is equal to 1 upon 3 is also given. We have to put these values here and simplify. So right hand side becomes tan A is half plus tan B is 1 upon 3 divided by 1 minus 1 upon 2 into 1 upon 3. And this is equal to, we can write 1 upon 2 plus 1 upon 3. LCM becomes 6. 3 plus 2. Now denominator 1 minus 1 upon 6. So this becomes 6 minus 1 divided by 6. Okay. 3 into 2, 6. 6 into 1, 6. Minus 1 into 1, 1. Divided by 2 into 3, 6. So this is equal to 3 plus 2 is 5. 5 upon 6 divided by 6 minus 1, 5 upon 6. And 5 upon 6, 5 upon 6, which is equal to 1. So this is equal to 1. Hence tan of A plus B, its value is 1, and which is answer. Let us solve example number 4. If tan of x plus y is equal to 3 upon 4 and tan of x minus y is equal to tan of x minus y is equal to 1 upon 3, then find tan 2x. Here we have to find out tan 2x. Let us solve this sum. Solution for this. You know tan of x plus y is 3 upon 4 and tan of x minus y is 1 upon 3. If we take addition of x plus y and x minus y, that gives 2x. Okay. So we can write here tan of x plus y plus x minus y. This is equal to tan of x plus y, okay, plus tan of x minus y divided by 1 minus tan of x plus y into tan of x minus y. Assuming x plus y is equal to a and x minus y is equal to b. Tan of a plus b. is equal to tan A plus tan B divided by 1 minus tan A into tan B. We are applying this formula. Now on left hand side, this we can simplify. Tan of left hand side becomes x plus y plus x minus y, and on right hand side tan of x plus y is 3 upon 4 plus tan of x minus y is 1 upon 3 divided by 1 minus tan of x plus y, which is 3 upon 4 into tan of x minus y 1 upon 3. Okay, so now we can simplify this. Here plus y and minus y gets cancelled on left hand side. So left hand side becomes tan of x plus x, that is 2x, and on right hand side LCM of numerator, that will be 12. So 4 3 are 12, 3 into 3 9 plus 3 4 are 12, 4 into 1 4 whole divided by 4 into 3 12, 12 into 1 12, 12 minus 3, 12 minus 3 divided by 12 minus 3 divided by 12. So this is equal to, we can write 9 plus 4 13 divided by 12 whole divided by 12 minus 3 9 divided by 12. Okay, this 12, okay, again we can simplify this. This is equal to 13 upon 12 into 9 upon 12 can be written as 12 upon 9. Now this 12 and this 12 gets cancelled, and this is equal to, we can write 13 upon 9, and this is tan 2x, which is solution of given sum. Okay, let us solve next sum. Sum number 5. If A and B are obtuse angles and sine of A is equal to 5 upon 13 and cos of B is equal to minus 4 upon 5, then find A sine of A plus B, B cos of A plus B, C tan of A plus B. Okay, so we have to find out these trigonometric ratios, and what is given? Sine A is equal to 5 upon 13 is given, cos B is equal to minus 4 upon 5 is given. From this we have to find out cos A. From this we have to find out sine B, and then you can use the formulae for compound angles, and easily you can find these trigonometric ratios. So to solve this sum, since we know trigonometrical identity sine square theta plus cos square theta is equal to 1, we have to apply this identity. Replacing theta by A, we can write sine square A plus cos square A is equal to 1. We know value of sine A. Sine A is 5 upon 13. This can be written as, we want cos A. So take this sine square A on right hand side and keep cos square A on left hand side. Okay, so here we can write cos square A is equal to 1 minus sine square A. But you know sine A is equal to 5 upon 13. Hence sine square A can be written as 5 upon 13 square of this, and which is equal to 25 upon 169. Okay, 25 upon 169. So put here, hence cos square A is equal to 1 minus 25 upon 169. So right hand side, after simplification, on right hand side we get denominator 169, 1 into 169 minus 25, and which is equal to 144 divided by 169. Okay, but we want cos A. This is cos square A. Taking square roots on both sides, cos A is equal to square root of 144 divided by 169, and this is equal to plus or minus 12 divided by 13. Now we have to decide here, either cos A will be 12 plus 12 upon 13 or cos A will be minus 12 upon 13. Okay, depending upon that angle A lies in which quadrant. Okay, since sin A ratio is 5 upon 13, which is positive, so angle A may lies either in first quadrant or in second quadrant, because in first quadrant and in second quadrant sin ratio is positive. So if we assume A lies in first quadrant, if A lies in first quadrant, then in first quadrant all trigonometric ratios are positive. Hence cos A will be, this is equal to plus 12 upon 13. And if suppose angle A lies in second quadrant, then cos A will be minus 12 divided by 13, because in second quadrant cosine ratio is negative, okay, but sine ratio is positive. So there are two values of cos A, either 12 upon 13 or minus 12 upon 13. Let us decide afterwards. Before that, with respect to cos B value, we have to find out sin B. Since cos B is equal to, what is given? Cos B is equal to minus 4 upon 5. Let us find sin B. So sin B is equal to, using trigonometrical identity, sin B is equal to, we can write square root of plus or minus, you can put here 1 minus cos square B. Okay, so this is equal to plus or minus square root of 1 minus, cos B is minus 4 upon 5, minus 4 upon 5 square of this, which is equal to plus or minus square root of, which is equal to plus or minus square root of 1 minus 16 divided by 25. Okay, again this is equal to plus or minus square root of 25 minus 16 divided by 25. Again this is equal to plus or minus square root of 25 minus 16 is 9 divided by 25. So sin B will be either plus or minus. Square root of 9 upon 25, that will be 3 upon 5. Okay, but here cosine ratio is negative. Cosine ratio given, it is negative. So B must lie either in second quadrant or in third quadrant. Okay, so B must lie in second quadrant or third quadrant, because in second and third quadrant cosine ratio is negative. And if we assume B lies in second quadrant, then sin ratio in second quadrant, that will be positive. Hence sin B will be plus 3 upon 5. And if B lies in third quadrant, in that case sin B will be minus of 3 upon 5. Let us write this conclusion. If B lies in second quadrant, then sin B is equal to plus 3 upon 5. And if B lies in third quadrant, then sin B will be minus 3 upon 5. Okay, remember this. Now we have to calculate trigonometric ratios. Here it is clear that A lies either in first quadrant or second quadrant. Let us assume A also lies in second quadrant, due to which sin A is positive, and B also lies in second quadrant, due to which cosine ratio is, cosine of B is negative. Assuming A and B both lies in second quadrant, let us find result. So assuming A and B both lies in second quadrant, given that sin A is equal to, sin A, its value is given 5 upon 13, and considering A lies in second quadrant, we have obtained cos A, and cos A is equal to, in second quadrant cosine ratio is negative, so cos A is equal to minus of 12 upon 13. As well as we are assuming B also lies in second quadrant, and given that cos B is equal to minus 4 upon 5. Okay, this is given. This implies in second quadrant sin ratio will be positive. Sin B is equal to, its value is 3 upon 5. 3 upon 5. So assuming these values, let us find sine of a plus b. So statement A, sine of a plus b is equal to sine of a cos b plus cos a into sine b. Put the values. Sine A is 5 upon 13 into cos b is minus 4 upon 5 plus cos A is minus 12 upon 13 into sin B is 3 upon 5. Let us take its multiplication. So this is equal to 13 into 5, 65 LCM. Sorry, this is multiplication. So 13 into 5, 65, and in numerator 5 into minus 4, that is minus 20, plus here also 13 into 5, 65, and in numerator minus 12 into 3 minus 36. LCM denominator is same, so we can take LCM 65. So this is equal to 65 in numerator minus 20 minus 36, and this is equal to minus 56 divided by 65. This is value of sine of a plus b. Let us find value of second statement, that is cos of a plus b. Cos of a plus b is equal to, we can write cos a into cos b minus sin a into sin b. Okay, so this is equal to cos a is minus 12 upon 13 into cos b is, here cos b is minus 4 upon 5 minus sin a is 5 upon 13 into sin b is 3 upon 5. Simplify this. This is equal to 13 into 5, 65, and in numerator minus 12 into minus 4, 48, minus 13 into 5, 65, and in numerator 5 into 3, 15. So we can take LCM as 65. So this is equal to 65 in numerator 48 minus 15. And 48 minus 15 is 33. So this is equal to 33 divided by 65. This is value of cosine of a plus b. Let us find value of tangent of a plus b, okay, which is third statement. So tan of a plus b is equal to, we can write tan a plus tan b divided by 1 minus tan a into tan b. But we know tan a is equal to sin a divided by cos a. And what is value of sin a? Sin a is equal to 5 upon 13 divided by cos a is equal to cos a minus 12 upon sin a is equal to 5 upon 13 divided by cos a is minus 12 upon 13. Hence tan a is equal to, this is equal to minus 5 upon 12. Similarly, let us find tan b is equal to, tan b is equal to sin b divided by cos b. But sin b is 3 upon 5 divided by cos b is minus 4 upon 5. So 3 upon 5 divided by minus 4 upon 5, this is equal to minus 3 upon 4. This is value of tan b. Okay, now put these values on right hand side. Hence tan of a plus b is equal to tan a, that is minus 5 upon 12, plus tan b, that is minus 3 upon 4, whole divided by 1 minus tan a into tan b, minus 5 upon 12 into minus 3 upon 4. So this is equal to, in numerator LCM will be 12, and then minus 5 minus 9 divided by, in denominator 12 into 4, 48, minus minus plus, plus minus minus, 5 into 3, 15 divided by 12 into 4, 48. Okay, so let us simplify this. This is equal to minus 5 minus 9 minus 14 divided by 12 whole divided by 48 minus 15, 33 divided by 48. Okay, let us simplify again. So this is equal to tan of a plus b is equal to, after simplification, this is equal to minus 14 divided by 12 into 48 divided by 33. This is equal to 12 of 4 ja 48, 4 into 14, 56. This is 56 divided by 33. So answer is 56 divided by 33. Minus of 56 divided by 33. This is final answer. So let us stop here. Thank you. Thank you all. Thank you for watching this video. Thanks.